True or false? Polynomial functions are continuous. So polynomial functions, the graph of them doesn't have any holes. Polynomials, no holes or breaks or going to infinities. So I guess nor. And therefore they are continuous. Correct. 2. X equal to negative 2 is a vertical asymptote of r of x equal to r of x equal to x squared minus 4 over x plus 2. Typically, what we do is we try to basically find the zero of the denominator. But before finding the zero of the denominator, make sure that this is not, you cannot simplify this. And you can simplify this because x squared minus 4 factors into x minus 2 times x plus 2 over x plus 2. So the simplified form of the rational function is going to look like this. Simplified form that's within the domain, it's going to look like this. So everywhere but at x equal to negative 2, this function is just a linear function. Linear function y equal to x minus 2. Therefore, it doesn't have a vertical asymptote. It just has a hole, basically. That said, this is false. Please remember, if, for example, this was x squared plus 4 over x plus 2, this actually x minus 2 was a vertical asymptote because x squared plus 4 cannot be factored into two linear factors, two real linear factors. These roots are complex. So that's that. Now let's do number 3. It says x equal to 2 is a vertical asymptote of f of x equal to e to the power negative x plus 2. True or false? The exponential functions don't have any vertical asymptote. So any function of this form, basically a e to the power bx plus c doesn't have a vertical asymptote. Does not have vertical asymptote. But note that actually f of x equal to e to the power negative x plus 2 has a horizontal asymptote. And that is as x goes to positive infinity, right? As x goes to positive infinity, the exponent goes to negative infinity. Therefore, the e to the power, that exponent, goes to 0. Therefore, f of x goes to 0 plus 2, which is 2. And that means that y equal to 2 is the horizontal asymptote. Now, number 4. Number 4, consider g of x equal to 3e to the power negative x. The right-hand behavior of g of x as x goes to infinity is g of x going to 0. Let's talk about right-hand behavior is as x goes to positive infinity, left-hand behavior as x goes to negative infinity. So the right-hand behavior as x goes to positive infinity means that the exponent, here the exponent, negative x goes to negative infinity. Therefore, e to the power negative x goes to 0 as the exponent goes to a negative infinity. The exponential goes to 0. Therefore, g of x goes to 0. So this is a correct one. And that was false, by the way. There we go. Now, number 5. If a continuous function f satisfies f of negative 1 equal to 4 and f of 8 equal to negative 3, f must have a 0 between negative 1 and 8. So f of 8, let's say this is the x-axis. F of 8 is negative 3 down here. 8 and negative 3. And f of 1 is 4. F of negative 1. I'm sorry. And so, and the function is continuous. By intermediate value theorem, the continuous function takes all the values in between the two of them. It can go however it wants. It still has to be function however it wants. The graph of the function can be however it wants, but it has to be a function. But it has to intersect the x-axis. That means it has to take the value 0 between negative 3 and 4. So this is true by intermediate value theorem.